Today, we will be discussing ELISA, which is both a quantitative and a qualitative laboratory technique. ELISA stands for Enzyme Linked Immunosorbent Assay.
The primary purpose for ELISA is to measure the concentration of analyte in a solution. This is mainly used to detect and measure antibodies in your blood, and thus it is used as a screening tool for various diseases. ELISA results in a colored end product which correlates to the amount of analyte present in the original sample. This concentration is then quantified and compared for analysis.
The typical materials you will need for running an ELISA consist of a well microplate, detection antibodies, standards, your HRP conjugates, your diluent buffers, your wash buffers, usually 1x PBS, chromogenic substrates, stop solutions, plate covers. For a specific experiment, you will need absorbance-based microplate reader, distilled or deionized water, squirt wash bottle, or an automated well plate washer, and your sample antigens.
Procedure. Step 1. Add antigen solution to the well plate. Step 2. Let the solution in the well plate come to room temperature. This takes about 5 minutes. Step 3. Remove all liquid from the well plate. Step 4. Wash with PBS and then remove the PBS. Step 5. Add the necessary reagents to the well plate. Step 6. Incubate the well plate at about 37 degrees Celsius. Step 7. Remove all the liquid from the well plate. Step 8. Wash with PBS and once again remove the PBS. Step 9. Add the necessary secondary antibodies to the well plate. Step 10. Incubate once again, but this time incubate for about 15 minutes. Step 11. Prepare the detection substrate. Step 12. Remove and wash with PBS. This will be your final wash with PBS. Step 13. Add the necessary substrate solution to the well plate. Step 14 will be to incubate one last time. Depending on your protocol, you will need to make necessary adjustments. Step 15 is to remove from incubation and examine your results.
A deeper look into the molecular level shows that the wells are coated with antigen and then filled with substrate, usually from patient serum. If antibodies are present, they will bind to the specific antigen receptors. Unspecific antibodies are washed out, usually by 1x PBS. Secondary antibody will then bind to primary antibody covalently. A solution of colorogenic enzyme substrate is added, and then the solution will change color, indicating a reaction has occurred.
Visual inspection will show that a reaction has occurred due to the color change. The intensity of the color will determine the concentration of antibodies. As you can see, the darker the color, the higher amount of antibodies in the well plate.
ELISA is very popular due to the ability to quantify its results. In this specific example, we see the antibody titers produced in mice against a vaccine that targets human alpha-synuclein.
Problems in this assay can occur due to incorrect pipetting, contamination of your equipment or your sample, etc. Incubation at high temperatures will cause denaturation of your sample or antigen. Incorrect washing and other systematic and random errors can also lead to problems with the assay results. Overall, ELISA is a very useful technique.
Thank you.